If you watched my DDPM video, then you know diffusion models can generate incredibly realistic images. But there was one problem nobody had solved yet, and they were way too slow and way too expensive. Then this one came out, and they released it for free. So that's why you can run Stable Diffusion model on your laptop today. So before this paper, diffusion models existed. They worked, but they had one massive problem. Training to hundreds of GPU days and generating a single image way too slow for anyone to actually use. So here's where it gets interesting. There are actually two kinds of compression. Perceptual compression removes details your eyes can't even see anyway. Semantic compression learns the actual meaning of the image. The insight here is do perceptual first, then run diffusion in that smaller space. This is the whole trick. Compress the image down with an encoder, run diffusion in that tiny latent space, then decode it back up. 8 times smaller and 48 times faster, almost zero quality loss. Step 1 is training the autoencoder. Encoder compresses the image, decoder reconstructs it. And look at this, their reconstruction quality beats DAL-E at the same compression level. This is the full pipeline from the paper. Image goes in, encoder compresses it. UNet runs diffusion in latent space. Decoder brings it back. And the conditioning, text, image, whatever, comes in through those cross-attention layers on the right. The UNet starts from pure noise and removes it step by step until you get a clean latent. And compared to DDPM, instead of touching millions of pixel values every step, it's only working on 64 by 64 latents, 64 times fewer values, the same result. So how does your text prompt actually affect the image? Cross-attention. At every denoising step, the UNet takes a query from the latent and keys and values from the text encoder. That's literally how a squirrel eating a burger becomes an actual image. These are real outputs from the paper. Text to image on 1.45 billion images. Look at this, a zombie in the style of Picasso. A continuous neural network. This is what the model produces. They tested different compression levels. LDM4 hits the sweet spot, fast and high quality. Too much compression and you lost quality. Too little and you're back to being slow. LDM4 is what became Stable Diffusion. Same exact architecture, just different conditioning, feed in a low-res image, and the model fills in the details. It actually outperformed Google's SR3 model. Same architecture, different input. Mask out a region, set it to 0 in latent space, and the model fills it in based on everything around it. This is literally what Photoshop's generative fields is built on. They open sourced it and that changed everything. Stable Diffusion, Photoshop AI Fill, Sora, Runway, all of it traces back to this one paper. It's not perfect. Inference is still sequential. Training data biases show up in the output, and generating readable text inside images still broken. But these limitations are exactly what drove ControlNet, SDXL, and everything after. They didn't make diffusion faster by making it more complicated. They just asked, where does the computer actually need to go? And then they open sourced it. Stable Diffusion, ControlNet, none of it exists without that one decision. 5 things: latent space, not pixel space, autoencoder first, across attention connects text to image, same architecture for everything, and open sourcing this created an entire industry. Next time you generate images and you will know exactly how it works, and that's Stable Diffusion.